Hello, myself Professor Harish Bangade from Department of Electrical Engineering, SND College of Engineering and Research Center, Evla. So we are discussing the basic electrical engineering. In that, we are discussing alternating current. So today, I welcome all of you in part 4. And in this part 4, we will discuss about the average value. So already we have discussed what is RMS value or effective value and how that RMS or effective value can be found out or calculated using graphical as well as analytical method. So today we will see what is the average value and how analytically we can calculate the average value. So here the average value of one cycle is shown. Now before how to find the average value, okay, before that we will define what is the average value. So the average value of an alternating quantity. So this is alternating waveform is shown, alternating quantities waveform is shown, that is sinusoidal waveform is shown. The average value of an alternating quantity is defined as that value which is obtained by averaging all the instantaneous values over a period of half cycle. Now here the half alternating quantity we know it is composed of positive half cycle and negative half cycle. So one complete cycle constitute positive half cycle and negative half cycle. Now if we find out the average value for all the points, that is for positive half cycle as well as for negative half cycle. Now we know the instantaneous values of positive half cycles at each instant of time have a positive value, and the instantaneous values at each instant of time has a negative value. And if we take the average of this positive and negative, then the average value for all these points I will get the as 0 if we consider the sign. So the average value of a sinusoidal signal is always find out for only positive half cycle. Or in other words, we can say that the average value for positive half cycle is equal to the average value for the negative half cycle, but the signs are opposite. So for a symmetrical AC, the average value over a complete cycle is 0, as both positive and negative half cycles are exactly identical. Hence, the average value is defined for half cycle only. So the average value can also be expressed by that steady current which transfers across any circuit the same amount of charge as is transferred by that alternating current during the same time. If we have connected the alternating quantity or the steady current, DC current, to a certain circuit, and for a particular time, if that current will transfer the particular amount of charges, then the same amount of charges will be transferred by the alternating current, and that current is known as the average value. So analytically and graphically, we can find out the average value. So now we'll find out the average value analytically. So this is the analytical method for finding the average value. So consider the sinusoidal varying signal I is equal to Im sine of theta. So this is the corresponding waveform, or I is equal to Im sine of theta. Now this figure shows a different instantaneous current, right? At particular instant of time, I is equal to I1, I2, I3, like this. Okay, now consider elementary interval only we consider, and during that interval, the average instantaneous value, let us say during d theta interval. Okay, so this d theta interval we consider. During that d theta interval, the average instantaneous value of a current is said to be I. Okay, that is, let us say it is I, and that average instantaneous current during d theta is I is equal to Im sine of theta. Now I average, we have the formula for I average. That I average can be found out as the ratio of area under curve for half cycle. Ratio of area under curve. We will consider this half cycle. हाफ साइकिल के नीचे जितना भी एरिया आता है, that area. So area under the curve, it is the ratio of area under the curve to the length of the base over the half cycle. The half cycle का in time interval का base जो है, that is 0 to pi, means it is pi. So it is average value is nothing but the ratio of the area under this half cycle upon pi. Okay, so it is I average is equal to 1 upon pi, and integration area under the curve, it is nothing but integration from 0 to pi I d theta. So the limits are taken from 0 to pi because we are considering only first half cycle. Okay, and for whole cycle, the average value of sine wave is 0. So the average value is 1 upon pi integration of 0 to pi. I is equal to now Im sine of theta. So put that Imx sine of theta d theta and is equal to 1 upon pi Im, and integration of sine theta is minus cos theta, and its limit is from 0 to pi. So solve for this limit 0 to pi, and we will get I average is 1 upon pi Im into bracket, it is 1 minus minus 1, so it is 2, and it is 2 upon pi Im. So I average is always equal to 0.637 Imax. So you remember I average is always 0.637 Im. If it is a voltage, instead of current, we have considered voltage, then V average is always 0.637 Vm. Okay, so last time we have find out the RMS values. RMS value is always 0.707 Im, and I average is always 0.637 Im. So you remember these formulas will be helpful for solving the problems. Thank you. Next time we'll see the next topic.